Okay, everyone, we are going to read part 2 cognition. The chapter of visualizing for the mind. Okay, this chapter is going to be really fun too. Let's get started. So we are here in the part cognition, and we are here visualizing for the mind. This chapter mostly focus on still how the eyes work, and it mainly focus on how the how the eyes and brains group stuff, put stuff together, or differentiate stuff, consider things that belong, that doesn't belong. Okay, let's see. At the beginning of this chapter, it started with an example showing the brain loves a difference. Please look at these two pictures. What do you see in the picture? How quickly can you see the wolf in the trees in each of these illustrations? I would say, I see a wolf pretty quickly in both of these two pictures, but in the third picture, almost didn't see the wolf. And between these two pictures, it seems quite identical to me, and maybe this one is more clear. There is a wolf, and this one is a little bit less clear. But still, I just feel, it is for sure this picture make me feel there seems to be no wolf over there. By looking at this picture playing this game, we know for sure that, it's an experiment. We know for sure our eyes and brain quickly detect the shape very quickly. So we see that the brain is much better at quickly detecting shade variation than shape differences. Well, so for here, there are the shape representing the tree, there are the shape representing the wolf, but they are, in the same color, which means that there is no shade difference, shade variation. But the first two pictures show shade variations. We feel it's much more obvious for us to see the wolf. Our brain work in a way, and eyes work in a way that they can detect shade variation better than shape difference. Just like here, this is another example for us to realize this. Let's try to identify where are the 6 in the pictures. The first big picture, if we want to detect 6, we have to look at the different shapes. Well, there is a 6 here, 6 here. But for this picture, the 6 are differentiated than other numbers using shade variation, using different colors. So it is so obvious that our eyes and brain are detecting differences using some molecular mechanism. Okay, for this example, it's almost the same, which is easier for us to identify the type 1 and type 2 in different states. Well, so if they are drawn as the same color, has different shape, it is like very complicated for us to detect the difference. But if we are directly draw the different color, the different shape, also with different color, then this becomes much easier. In other words, our eyes and brain just work in a way that is very easy to detect the shade difference, the color difference, than the shape difference in this example. There is actually a school of thought and pattern recognition. They are doing research about how our brain and our eyes work together. There are different features of the pictures that can be shown to our eyes and brain, including the size difference, orientation difference, and color and shade difference, which is more obvious. Some features that the brain is able to detect pre-attentively, which means that we are able to detect the patterns and features using our brain and eyes. Okay, from here we are going to discuss about two things. One is that how do we show some of the things are in a group. The other is that how do we show things are different from each other. Well, so just like what I have been written in my note, there are two things we are going to pay attention to. One is how the eye see things as groups, how to allow similarity, how to show similarity in visualization. The other is how the eyes differentiate things, how to show difference in visualization. Okay, let's start. Looking at these three pictures, you are going to feel that there are three groups over there, one group here, two groups here, three groups here. There are four groups here, 1, 2, 3, 4, and for here, each column you may feel they are in a group. Well, so why we feel this way? We feel that actually objects close to each other will be perceived as belonging to a group. So the first thing to show that some of the things are in a group is by putting things close to each other. Then it seems to be in a group. This example is an application. Well, for this example, it shows the first representation is better than the second one because actually, this part above belongs to one group. If represented this way, then people are going to confuse about what these three are trying to illustrate. So as we know, to group things together, the first way is just to simply put them close to each other. The second method is using similarity, and this similarity can be color, can be shape. So basically, objects look alike will be identified as parts of a group. So in here, well, so firstly, if we want to group them, you may feel this is one group, this is three, this is second, this is the third. Also, as this all red colors, you may feel they are one group. All the orange colors, you may feel they are one group, and the blue, you feel they are one group. Here, in this picture, you may feel all the green colors belong to one group, and the rest is another group. In here, you may feel there might be three groups: the state with nothing in it, the state with a dot, and the state with the star. So they show us that similarity also can group stuff together. Well, so here we have two. Second, similarity. First, close to each other, connect. And the third one is connectedness. Okay, so for this picture, it is easy for us to distinguish all the things that are connected with each other using a line is identified as a group. And all the rest are not this group. So basically, connectedness can also create groups. The last method mentioned here is continuity. Or basically, it is illustrating about how to connect stuff together, but it prefers the connecting without a lot of angles, which are smooth. This way make us feel easier to identify manager. 1 is connected with manager, 2 is connected with manager, 5, like that. Well, if we are using the angled line instead of the smooth line, it is just feel so not intuitive, not so direct and comfortable to see the groups, to feel the connectedness, the group. Okay, and another one, oh, I believe this is the last one, is about closure. So if you want to say this is one group, just simply draw a circle, draw a rectangle on the group. It is easily for us to detect, that is one group out there, that is another group out there. Okay, so this method is by closure. And the example is that, too many closures are going to cause confusion. So sometimes because closure can represent connectedness, sometimes we may even prefer there's no closure if actually we don't want to divide them into different categories. Okay, and from here, we are going to show that trying to group stuff, which is at the same time, the things in a group are similar. The things are not in a group are considered to be different. What are the different measures to show the difference? Well, this is one example. You can show the different groups out there by grouping them like this, or by grouping them like this. There are a lot of examples here, but actually, how to compare these different methods. You can also use colors to show difference. But the eyes might be more sensitive to some of the methods, less sensitive to other methods. Here is one example. If we want to show there are difference in the quantity, like here is 10, here is like 18, here is 7, 12, like that, then 10 and 7 are described as numbers, and we use a bar chart to show the difference. If we design using this, shape, like if we design using how large, the largeness of the shape to represent the number, then the 7 and the 10 seems to be identical, right? They look pretty similar. If we use the color to show the difference, if like this, the stronger the color is, the more the number is, it's still not super clear. This example shows us that a bar chart might be easier for us to see the difference if we want to show the difference. And there are many other methods too, but the author apparently show us that sometimes if you want to show the difference, it's good to use a bar chart instead of using colors. So like here, a bar chart like here is like, and also with ranking, it's just so clear about what are the numbers and relationships. But if using colors, this is very famous, very popular method. It may not be as effective showing the difference in numbers. Okay, let's continue. And we can also use other methods to show the difference for analyzation purpose. Well, at the end of the chapter, it shows us that trying to distinguish stuff, sometimes the depth is also involved, because our system of eyes and brains working together to distinguish objects, sometimes by imagining the space as three-dimensional. So for here, if seeing such three different pictures, we may firstly consider them as three-dimensional, and the stuff at the top, which means that all light are here and bounce back to our eyes, are not shaded, are considered one piece, and the other stuff that are shaded might be considered other pieces, other components. So basically, to differentiate different things other than the connectedness, other than some methods mentioned above to show the similarity. It is from the very beginning. To put things close together, from here, to put things close together, or using similarity, or using connectedness, or using closure. Is another method that we are using every day, but was not put up there, which is that about related, which is related with three-dimensional representation. Okay, I wish this chapter help us understand more about for visualization. What are the methods showing similarity? We can group them together. We can use similarity. We can use connectedness and closure to show things that are similarity. And how do we show things that are different? Well, so if you are grouping things, then you can show the difference, like by, for example, give different colors or show them as a bar chart. We can also show difference using visualization. And a different method of showing difference may let our eyes and brains feel different. So basically, there are better ways for visualization and worse ways for visualization depending on the different purposes. Great. That is this part about cognition, part 2, and the chapter of visualizing for the mind. Our mind using particular ways for grouping people, grouping things, and also use different ways to differentiate things. Therefore, we can use different visualization methods to group things and differentiate things.